The very first thing I need to do is design the base. So we're going to start with, here will be our lamp, right here. On top of here, we're going to have a flame bulb inside of here. And that's going to run on 3 volts, but it's going to connect into a 6.3 volt DC. Normally they operate on AC power supply, but I have an adapter, a transformer built into my power supply that converts the AC into DC so I can use LEDs. Now the LEDs, of course, are all 6.3, so we're going to have to downstep it to 3 volt. So we're going to have to build a downstepper to downstep that from 6.3 to 3 volt, because if not, we will definitely fry it at 3 volt. The lamp is not only 3 volt, but it's also 6 watts. So we have to divide 3 by 6 to get our amount of amperage we need. It's going to use a 1/2 amp. Yeah, that ought to work. But to be safe, because I have other lights, I'm going to put 2 flame tea lights. Time to work on this. But these are all 3 volt also. But I want to say that they're probably 1 watt. I want to say they're 1 watt. Yeah, I want to say they're 1 watt. So that's going to be... We could probably tie 1, 2, 3, 4. So this is probably going to be about 1, 2, 3, 4 plus this. I think we can get away with a 3 amp downstepper. So here we have a plain Jane lamp I bought at Walmart, put a little cricut design on. I've added a little bit of black spray paint and rubbed it off to make it look like soot. And as you can see, it looks a little bit better now, but then I had to go and make it look antiqued. So I had to add a little bit of gold wax rub and buff. So now it looks like an old-timey lantern. Now here's our really, really, really cool flame bulb. It's not as cool and realistic looking as the box would lead you to believe. But it still does a really neat flame effect. Not nearly as cool as that. But as you can see, we have standard lamp bases that it screws into. Now lamps, especially the ones that use your typical light bulb screw-in, use AC power. That is a problem for us because we want to use DC power or battery power or transformed direct current power. So how are we going to change this guy into battery power? Well, let's cut it apart. I found that it had a small little transformer in it that converted it down to DC power, and it used almost no voltage at all. So inside of this lamp base, you have a AC-DC transformer. There's a little transformer right there in the center. You have some power filtering caps right there, some capacitors. They basically filter the power down or store a little power so that the little chips on there have a constant voltage. I see my, that right there looks like, so you can see right here, we have this little surface mount voltage regulator. And that is, I can tell by the serial number on that and the model number, that is a 3 volt voltage regulator. So one of my favorite tools I use here down in the engineering lab, or as I like to call it, my basement of doom, is my DC lab switching mode power supply. And what's nice about this is every piece of equipment that you have is different voltage. Most things are 5 volts, but they're all different amperage. So what's nice about this, if you follow the cords all the way down here, is that on the other end of this, I got 2 little alligator clips. And because I know this will accept a 6.3 volt, I've got that plugged into here. And now what this does is it transforms or downsteps incoming voltage. There we go. It downsteps incoming voltage to much lower voltages. All right, so that's in there right now. It's set to the positive, negative. Right here you have a potentiometer to adjust the voltage down. And I want it to go from 6.3, which is the incoming voltage. I want it to go to 3.3, which is what your standard LED bulb in your little votive candles run at. So I'm going to now test with one hand on my handy dandy multimeter. And this would be so much easier with 2 hands, or at least a tripod. When I go back into the office tomorrow, I will definitely have a tripod. So what I'm going to do is I'm going to probe the positive and the negative, and hopefully adjust this little knob with a screwdriver on the other end to turn it up and down to 3.3 volt. Don't touch the side. It's so much easier when I have 2 hands. And I got it adjusted down to 3.3 volts. Hey, your number 1 tool if you are going to do any kind of electronics repair or electronics assembly, you've got to have a really, really good soldering iron. Now, I've had many over the years. Everybody sort of starts off with a little cheap Weller plug-in model or the free one came with your toolkit. They are okay. You can get pretty good results with them if you take care of them. What's the number 1 ways we take care of our soldering irons? Well, a lot of the cheaper ones come with a little foam sponge that you can wet, and you'll take your wet sponge and you'll clean off your tip of your soldering iron in the wet sponge. But the problem with this is 650 degrees Fahrenheit. Let me zoom in here. It's sort of hard to see against the white background. But this is currently 650 degrees Fahrenheit. This is a digital digital one, so I can set the temperature properly. 650 is a pretty good temperature for all around soldering, especially with electronics. You want to get in there and out fast. So if you have it too cold, like say you have it at like 550, you'll sit there with your soldering iron on your electronic for far too long for it to heat up enough to heat your solder, and you'll end up destroying your part you're working on. But if you got 650, you can melt that solder real quick, and that way you're in and out before you burn your chip up or your component. Now, if you're working with, say, a heat sink or something that's like big, heavy metal, you're going to have to do one of 2 things. You can leave it at 650 and put a thicker tip on here. Let's see if I can get a good sort of focused in shot of that. You can put a bigger tip on it, and that way you can disperse that heat across bigger components easier. Or you can crank it up like another 50 to 100 degrees and then try to heat your heat sink up. But just make sure that what's attached to your heat sink isn't very sensitive, especially not sensitive to heat, because you'll end up, by the time you melt your solder, melting whatever you're trying to solder. So instead of using your little sponge to clean with, the problem with a wet sponge is cold. This is very hot. You put hot metal on cold, you're going to end up breaking and chipping up your tip. Let me get the little zoomy in here as I'm trying to do this with one-handed. All right, as you can see, my tip right here, it's a little dirty, a little pitted, but this tip is 4 years old and has seen thousands of hours of use. It's just a little pitted. It's just a little pitted, but still does the job very well for what I want to do, especially when I use proper cleaning techniques. Right here, we have ourselves a little bit of brass burlot. If I could look and see what I'm doing here, trying to hold a camera and do this with no depth perception. Just sort of go in there in the burlot, wipe it all up, And now I got a nice, shiny, clean tip. But if I really, really want to get this thing clean, there is, as I hold a very hot thing next to my phone, tip cleaner. Tip cleaner is about $5, and it's for when your tip is really, really dirty and really corroded or really rusty. You put a little bit of there while it's hot, and it's got a little bit of acid in there, and it will burn off whatever crud you have on your tip after it stops smoking. Put it right back in there. And really nice and shiny and ready to accept some tin. It would be nice if you would focus, but I don't have a good camera with me. We are using the phone. Okay. Now I can't do this one-handed in soldering, but we'll do some soldering tips tomorrow. Ready to solder, you're gonna need two things. First, you're gonna need some solder, which I have in abundance of on this little handy dandy roller, which I keep above my head. If I pull it down too hard, it will land on my head, which is why I screwed it into the base. I use lead-based solder. It flows really well into electronics and will give you lead poisoning. So please, 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 when you're soldering, always wash your hands like it's the coronavirus. Going down. Right here is my nice, wonderful, I wish it would focus, solder. I use a very fine solder. I do this because I work with very fine, small electronics, but this solder melts so nice I can use it with big stuff too. But it's always good to go small. That way you can work with your small stuff, and if you need big, buy big or use more small. The other thing you need when soldering is flux. But Mr. Boner, the solder says it has a flux core. That's great, but we want to make sure that our metal contact that we are soldering to is nice and clean. Whenever you get ready to solder a wire, you need to put some flux on that wire because oxygen is bad. I mean, it's good for us, but it's bad for metal. What happens when you leave a car out rusted with no paint on it? Gets rusty, gets nasty, gets oxidized. Same thing with your wire. You might not be able to see it, but there's oxidation on your wire. This liquid solder, when you put it on and you heat it up, it creates a chemical reaction that will eat that corrosion off of those wires and allow you to flow some solder into it. You want to put that on your surface that you're getting ready to solder and on your wires. You need to pre-tin your wires. It's so much easier to have solder already built into the wires. It'll allow it to flow much easier. So we're going to pre-tin some wires. Now, it's a little hard to see. Especially since I have spray painted the blue because I don't want to see the blue on it. It's a little hard to see, but inside, deep inside here, is an array of LEDs. Now, they are, let's see, I think they're a total of 6 watts. They are, I believe they're half-watt LEDs, so there should be 12 of them in there to have it equal 6 watts. And deep inside there, I mean, you can see another filter capacitor down there, but there's also a control board. This has a light pattern. It has 4 different light patterns, and by turning it on and off, it will change the different light patterns, whether it looks like a flame, whether it looks like a pulse, whether it's always on. We want it to always look like a flame, and because this is going to be plugged into a pinball machine where the lights flick on and off, I'm going to have to go in here and sort of jumper or disable the switching unit that every time the power goes on and off, or every time it reads or doesn't read power, it changes what type of light it is, or at the very least, jumper it or disable it. So here's an old-timey looking LED votive candle or a tea light. I'm going to have to take a measurement of the circumference of this. I'll use my digital caliper for that because I've got to make a base for this to rest in. But I've taken the battery out. It was a coin battery, 3.3 volt coin battery. And I see, luckily, we have contacts here. So I'm going to solder a wire to the positive and the negative. So here we are. We have stepped it down to 3 volts. And here's our cool flame effect bulb. that is running at a nice stable 3 volts. Now I could run this up to 5 volts. It'll be a little too bright for what I want it to do. I just want it to be an accent. I don't want it to light up the entire room. I just want it a nice little accent. And since this runs between 3 volts and 5 volts safely, 5 volt will give me a lot more brightness on the bulbs, but 3 has this nice, warm, fiery looking effect. We're going to leave it right at 3. Especially considering I'm going to tie in off of this board these little votive candles.